A very good morning to one and all. Myself, Professor Chetan Gupta, CSC Department, SIRT, the SAGE Group, and in today's lecture, we are going to discuss about the subject that is DBMS, that is a database management system. The subject code is CS502. And today's lecture, we will have to cover the topic that is transaction and schedules. So first of all, we need to understand the concept of transaction. Basically, a transaction is a unit of operation, or we can say that a transaction is a unit of program execution that access and possibly update various data item. In a simple word, basically transaction is a collection of operation that must be combined into a single unit, or we can say that a transaction is a logical unit of work that must be either entirely completed or no operation will perform. Basically, in this example, what we have seen that a transaction of $50 from account A to account B. So in first operation, we have read the variable that is A, then we have deducted the $50 from account A, then we have updated the variable A, then we have read the variable B, and then after that, whatever the deduction amount is there, we have added that amount into the B and we have performed the right operation. Means basically a transaction is a group of operations. Means here we have seen that the deduction of $50 from account A, then it will be credited into the account of B. So basically transaction is a group of operation. If we talk about transactions, so there are two main issues that are deal with the transaction. First is failure of various kinds, such as hardware failure and the system crash. And the second one, another issues related with the transaction is the concurrent execution of multiple transactions. Basically, if we talk about transactions, so transaction follow the ACID property. Here the ACID stand for A for atomicity, C for consistency, I for isolation, and D for durability. Basically, atomicity property require that either all the operation is specified in the transaction should be performed completely or none of these operation perform. Means basically atomicity property work on all or nothing rule. Either all the operation should be performed completely or no operation will perform. If we talk about consistency property, so consistency property ensure that the database remain in his consistent state before the start of transaction and after the transaction is over. Means whether the transaction is successful or unsuccessful. Basically, consistency state that only valid data will be written in the database, only valid data. If because of some reason a transaction is executed that volatile a database consistency rule, the entire transaction will be rolled back and the database will restore to a state consistent with those rules. The third one is the isolation property. Isolation property require that other operation cannot access or see the data in an intermediate stage during a transaction. Means each transaction is unaware of another transaction executing concurrently in the system. And last one is our durability. Durability property says that basically durability refer to the guarantee that once the user has been notified for the successful transaction, it will persist and not be undone even the event of failure and the system restarted or any other reason is there. Basically, if we talk about the stage of the transactions, so there are 5 different stage of the transaction: active stage, partially committed, failed, abort, and committed stage. These are the different stages of the transaction. If we talk about, if we want to know the diagrammatically, so these are the stages: active stage, partially committed, committed, failed, and abort. If we talk about definition, what is active stage? It is the initial stage of a transaction. A transaction goes into the active stage immediately after it start its execution, where it can issue read and write operation. If we talk about partially committed, basically partially committed means when the transaction finish or end and it moves into the partially committed stage. Then third one is the failed. A transaction can goes into the failed stage if the transaction is abort during its active stage. The transaction may roll back to undo the effect of its write operation on the database. If we talk about the abort stage, basically a transaction is enter in this stage when after the transaction has been rolled back and committed whenever we have a successful transaction. So it is known as committed stage. This diagram we have already discussed. If we talk about transactions, so basically what we have understood that transactions are executed in the concurrent manner. Means each and every transaction are performing. Means if we have a system, so there are a lot of transactions that are performing at the same time. So what is concurrent execution? Basically multiple transactions are allowed to run concurrently in the system. What are the advantage of that concurrent execution? First one is increase the processor and disk utilization and reducing the overall response time. Basically, concurrent curl scheme is a mechanism to achieve the isolation. That is to control the interaction among the concurrent transaction in order to prevent them from destroying the consistency of the database. So if there are concurrent transactions, so we need to identify the schedule. Means basically what is the meaning of schedule? Schedule basically is used to describe the order of execution. It basically assists the user that which transaction perform first and which second. So if we talk about the definition of schedule, when transactions are executing concurrently in an interleaved fashion, then the order of execution of operation from the various transactions is known as schedule. A transaction processing system usually allow multiple transactions to run concurrently in the system. However, there are two good reasons to allow the concurrency in the system. First one is to improve the throughput and resource utilization, and the second one is reducing the waiting time. If we talk about the type of schedule, so we have two type of schedule: serial schedule and non-serial schedule. If we talk about serial schedule, so here we taking an example that we have two transactions T1 and T2. T1 contain some group of instruction, T2 also contains some group of instruction, or we can say that operation. If we talk about serial schedule, so this is the example of serial schedule where the T1 has performed its operation. Whenever the T1 has finished its execution, after that the T2 entered into the system and completes its execution. Now here the T1 transaction is followed by T2. Means whenever the T1 transaction has completed its operation, only and only after that T2 will proceed. If we talk about non-serial schedule, so in a non-serial schedule, what we have seen in this example, that T1 has completed some portion of its operation. After that, whenever the variable A is free, immediately T2 will proceed it, and after the T2 is completed, half portion of T2 is completed. Now T1 is again come into the existence into the memory and completes its execution, and after T2. So it is a kind of non-serial schedule, or we can say that parallel schedule. So in today's lecture, what we have discussed what is transactions, what are the properties of transactions, what are the different stages of transaction, that is active, partially committed, failed, aborted, and committed. These are the graphical representation of different transaction stages. And after that, we have discussed what is concurrent execution, what are the advantages, or we can say that benefit to allow concurrent execution of a transactions. After that, we have discussed what is schedule. We have discussed two type of schedule: serial schedule and non-serial schedule. This is the example of two transaction T1 and T2. This example is shows the what is serial schedule, and this is the non-serial schedule. Okay, in our next lecture, we will discuss about the further lecture. Thank you so much.